This says, consider the following reaction. A plot of 1 over x versus time gives a line with a slope of 5.80 times 10 to the minus 2 molar second. So in this case, we have a second order reaction. How do we know that it's second order? Because we made y 1 over a with respect to time, and we made x time, and we got a straight line, which means this equation follows the general formula of the straight line, y equals mx plus b. We further know that k is equal to m, where m is the slope. So it asks, what is the rate constant for this reaction? Well, the rate constant is just the slope, which in this case is 5.80 times 10 to the minus 2 per molar second. The next question says, what is the rate constant expression, or probably better to say, what is the rate law for the reaction? So we want to know the rate law. Well, it's second order. We just figured out that it was second order. So in a second order reaction, the rate equals K times concentration of X, which is the only reactant, squared. So this is the rate law for this reaction. So we've now determined the rate law based on this plot information. It says, what is the half-life of the reaction when the initial concentration is 0.1 molar? Well, the half-life expression for a second order reaction is T1 half equals 1 over K times concentration of A0. So we can plug in. T1 half equals 1 over K times, in this case, the concentration of X, 0. So plugging in 1 over K, 5.80 times 10 to the minus 2 per molar second, times the initial concentration, which we're given here, which is 0.100 molar. And when we do that math, multiply these and then take the reciprocal, we find that it is 172 seconds. So the half-life of this reaction is 172 seconds when the initial concentration is 0.1 molar. Note that for a second order reaction, the initial concentration affects the half-life. So if the concentration isn't 0.1 molar, the half-life will be different, which decreases the utility of the half-life expression, but we can still calculate it. In the next question, it says, if the reaction starts with a concentration of X of 0.25 molar, what is the concentration of X after 185 seconds? Well, we need to remember a couple things. First of all, K is equal to 5.80 times 10 to the minus 2 per molar second. And that's very important. Now we can use the integrated second order rate law, which is 1 over the concentration of X at some time is equal to Kt plus 1 over the concentration of X initially. Well, we know the initial concentration of X, we know K, and we know T, so we can solve for this. 1 over the concentration of X at some time is equal to K, which is 5.80 times 10 to the minus 2 per molar second, times the time, 185 seconds, plus 1 over 0.250 molar. Now we need to simplify the math. 1 over the concentration of X at some time is equal to these two numbers multiplied by each other, which is 10.72 per molar, because seconds cancel out, plus 1 over 2.50 is 4.00 per molar. We add those together. 1 over concentration of X at some time equals 14.72 per molar. Take the reciprocal. So take 1 divided by 14.72, and what you get is the concentration of X after some time is equal to 0.0679 molar. So the integrated, in this case, second order rate law allows us to predict the concentration of this when it starts at 0.25 molar after 185 seconds. No, we do need K for that, but we got that from the information about the plot. Final thing is, what is the concentration of U after 185 seconds? So remember that X gas becomes U gas. So if we started with 0.25 molar, okay, these two questions are directly related to each other. So if this started at 0.25 molar and all of it became U, the concentration of U would be 0.25 molar because the stoichiometry is 1:1. But not all of it became U. Some of it's still X. So if we take the initial 0.250 molar and we subtract the amount that is still X, 0.0679 molar, we find that the concentration of U, the part of X that was converted to U in a 1:1 reaction, is 0.182 molar. So these two questions are directly related to each other, and we can solve for both the concentration of X after time and the concentration of U after some time. So I should have probably put here concentration of U, like that. So this is basically a very similar question to one that was done earlier, but now using a second order reaction.